Hello friends, welcome to this section of Go programming tutorials. So far we have seen the key concepts of Go programming language, and now we are at the end sections. These are all some set of last sections we are going to see as a part of core Go programming language. After this set of sections we will see some new advanced concepts in Go, but this set of tutorials with next one or two or three videos, we will conclude the basic concepts of Go programming language. Right. So now we are going to see about file input output. In the previous presentation or in the previous tutorials, we have seen the same file input output along with command line arguments. Now we are going to see a little bit deeper into file IO. Let us use the file IO now with some examples. In the previous example, we have seen IOUtil package in order to perform file input output. We used os package for command line arguments. Now in this section, we are going to use the same os package for file input and output. Let us see how os package helps us to perform file related operations. Let's open the command prompt. I will zoom it a bit, maximizing the screen, switching over to our regular folder, right? So now I'm going to create a file, filedemo.go, the same way, package main, import. Now what we are going to do, we are going to write the data into the file. So I'm not interested with fmt package. If we are reading, I can use the fmt package. So I'm going to write. For that I have to use the os package because we are going to use the os package throughout the day for now. Then I'm going to create a main function. Fine. So we are done with creating a simple main function. Now I'm going to create a file. So whenever we use IO package, right? So we just simply use io.write file and file name, sorry, io.util.write file and file name so that it will write the content into the file. Similar to this, in os package, there is a method called create. Sorry, there is a function called create, which carries a string argument, which is a file name. So I am going to name it as myfile. This is a new file. So I am trying to create a new file, myfile. Right? Okay. So it will return two handles for us. One is the file handle, another one is the error handle. So I will be getting both the things, error handles. So the similar way how we handle errors in the previous example, we will handle here as well. If error not equal to nil, so if error not equal to nil, what shall we do? So we used to raise a panic, right? So let us raise a panic or let us skip the errors for now. Whatever it is, that will be better for us. It is better, I think we can raise a panic. That makes sense, right? So if error not equal to null, let us raise a panic error. Right. So in the next section, what we are going to do, right? So no panics. So we need to open a file and we need to write some content into it, right? Right. So far we have seen we can deal with files only with byte arrays. So in the previous section, I told byte arrays as hexadecimal. Sorry for the mistake. The data in byte array stored during file operations and everything is octal. So they are 8-base data. So that is an octal data, not hexadecimal. I made some mistake in the previous video saying everything as hexadecimal. They are octal data, right? That's fine. Now, what we are going to do, we are going to write something into the file. So already we have a file handle with the name file. Error we have checked here. Now we are going to use the file handle to write the data. Before that, I need to prepare the data. So in order to prepare the data, I need to create a byte array. So first I need to create a data equal to, it is be a byte array. So here in the byte array, I need to create my data, right? So hello world, I am going to name it as hello world. So this is a very simple data. I am going to write it into the file. So this byte array I have initialized, which is with the name data. So this data I am going to write to the file. So what is the object of file handler? It is file. So file dot, there is a method called write. So which one I am going to write? I am going to write the binary data. So this data, this method returns two arguments. One is the number of bytes it wrote to the file. The another one is error handler. If anything is there, it will show the error. Now I am not interested with the error handler or number of bytes. So I am just going to write the data into the file. And after that, I am going to close the file handler. So how to close the file handler? File.Close. As simple as this. So this is the simplest program to write the data using OS package with the file handle file. So write data, the binary data should be given inside the write method. So this is a simple code. Now I am going to compile this. Go run filedemo.go. So now if you see ls, you can see a file called myfile. Cat myfile. See the output hello world is being written. So what we have given in the byte array is a string which got converted into a byte array and written inside the file is a string. This is one way of writing a byte array which is a string. Now we are going to see a method through which we will directly write a string in a file. So for that what I need to do? In order to write a string directly instead of a byte array, I am going to write a string directly. Right. So what I will do? I will comment this statement. So now I am going to write a string, right? So let these two statements be there. File.WriteString. This is a string. So this time I am writing a string to the file. Instead of creating a byte array with a string and writing the byte array, now what I am doing, I am directly writing a string inside the file. It is as simple as this. Write string, there is a method inside the file. Using this, you can just write a string. Now I am going to compile and execute the file. So if you see the output of my file, hello world, this is a string. Both the lines have been written. The first line is being written as a byte array and converted into string, and it is being written there. The second string, which is this is a string, is already declared as a string and written as a string. So this is how, so this is the way to write data as a string. This is data as a byte array. So both are the ways to write data to a file using the OS package. So this is how we write data. The next code we are going to see is how to read the data using OS package. So for that I am going to create a new file, readdemo.go, same way package main. So here what I am going to do, I am going to read the data from file and print it in the console. So I am in need of two packages. One is format, another one is OS. So both the packages I may need, and here I will write a function main. Okay, so there when we are going to create a file, we need to invoke os.Create. Now we are going to read the data from the file. So here I need to use os.Open. This is the statement I have to use. What is the file I am going to open here? So I am going to open the file myfile. I am going to read the data from myfile. So similarly, like create function, it also returns two handles. One is the file, another one is the error handle. So we can follow the same way. If error not equal to nil, so I can raise a panic of error. As simple as this. Now we have the file handle. Using the file handle, I am going to read the data. So how we wrote the data so far? We wrote the data as binary byte arrays. Now in order to read the data also, we need a byte array to store the values, and we have to convert it into string and print it to the screen. This is how the operation will perform. So in order to read the data, I need to define a byte array. So to create a byte array, already we have used some constructional methods for structs, and even in previous interfaces we followed some ways to create slices, arrays and all, right? The same way we are going to create a byte array also. So how? Using the same make function. So the make function will carry what I am going to make here. I am going to create a byte array. What is the size of the byte array I am going to create? I am going to create the byte array of size 3. Let us keep it as 3 for time being. So my byte array will be defined in the variable data. So data is the variable I am creating, which is a byte array of size 3. As simple as this. Now I am done with my byte array. So what I am going to do now, I am going to read the file, read the data into the byte array variable and print it on the screen. It is as simple as this. So how to read the data from the file. So we have to use the file handle dot read. This is the function I need to use. This read function carries one string argument. That string argument, very sorry. This read function carries a byte array as an argument. So all the data read from the file will be populated into the byte array. In our case, the byte array is data. So this statement will read the data from file to the byte array data, right? Okay, so the read function also returns two handles. One is the read, the file handle, that is the data, that is number of bytes read. Another one is error handle. For now I am not interested with any of these things. What I need is just the data which I read from the file. So the data we are read from the file is in the byte array data. Now I need to convert into a string and print it on the screen. So what I need to do, I need to convert it into a string and print it on the screen. So format dot printf, the file data is percentage yes, what I'm going to print, comma percentage yes, of course, new line. So it will be read as data. So data is the byte array I have read. I need to print it, right? So it is a string. So string of data. I'm done. So after reading the data from the file and all, already we have opened the file. So I'm going to close it also. So how we will close the file? We will use the same file.Close as we did earlier. So we used the write method to write a binary data. So read method to read the data into a byte array. So to writing and reading both are in the byte formats in Go programming language. So let us see what it reads from the file. So go run, sorry, it is an error, 10. So oops, two times I have given the array specifier, that is wrong. Yeah. See here, the file data is hell. See here, the output is, it just printed three letters. But actually, what does the file contains? The myfile contains two sentences. Hello world, this is a string. But it just prints only three characters for me. So what does it mean? Because the byte array has only the size as 3. So the data read from the file will be of the size of the byte array. So here the size of the byte array is 3. So the data read is being 3. So what I'm going to do now, I'm going to make it as 30. So if I save and exit and run the code, the file data is hello world, this is a string. So the entire set of data residing inside the file is being read now. So this is how we need to read the data from the files. So how much the size you are mentioning for the byte array, that number of data only will be read from the file. So in order to have huge set of file, huge set of data, we need to have bigger byte arrays to read the data, right? So this is one way of reading the data fully. Now what I am going to do, I am just going to mention the size as 5. If I compile and execute the code, so what is happening? The file data is hello. Okay, so now I am going to use a different statement in order to print instead of this format. Hello, it is being printed, right? So the file has 5 characters, sorry, the byte array has 5 characters, so it read 5 characters from the file. Now it reads, say if you see the content of the file, it shows hello world and this is a string. The 5 characters are hello, so it is being printed. But now what I am interested is, instead of printing the word hello, I want to print world. World is also of 5 characters, but what my requirement is, the file handler should not read from the beginning of the file. It should read from the middle of the file. So whenever you try to read some set of bytes, it reads from the first of the file, right? So that's why hello is being returned. Now I want the file pointer to be moved to this location, and from here it needs to read 5 bytes for me. That means it should not read the word hello, it should read the word world. That means it should skip this set of values and it should read from this position. This is what my requirement now. What I am going to do, there is a special function here available in Go programming language which is called as seek. using the seek, I can mention the number of characters I need to skip. So I need to skip 5 bytes. That means I want to seek the file pointer to the fifth byte of the data. So the data should be read from the fifth byte. So from the fifth byte, how much data I need to read? I need to read 5 more bytes. So let us see what's the output is telling here. See here, world. So it also includes the empty space because 5 includes the empty space. 0, 1, 2, 3, 4, 5. So what is happening is 5 characters from this empty space, which is world. So this is what being read from the Go compiler. So now in order to make it further better, what I will do, I will seek the file pointer to sixth position so that the empty space will be ignored and the data read will be world. So this is how we need to seek the file pointer anywhere in the file and read the data. So the file pointer needs to be moved based on the seek values. So the seek has two arguments. First argument is the position in which from where the data needs to be read from the file. The second one is from which place, whether from the starting of the file or from the end of the file. So 0 stands for starting of the file, 1 stands for from the position where the file pointer is currently in. So the file pointer is also in the starting. So even though if I type 1 and run the code, the same output will be there. So what does it mean? So the seek carries two. Seek has two arguments. First one is the position of file pointer to read data. Second one is from where in the file to read from. 0 means beginning, 1 at current position, 2 from end. So this is what the second argument in the seek says. So the second argument is now I mentioned as 1 because the file is new and we are seeking to the sixth position from 1. So the current file pointer is also in the beginning. So the output for 0 and 1 remains the same for us. Now for a change, what I am going to do here is 6 instead of 6 comma 1, I am going to mention it as 6 comma 2. So 2 means from end. So it will go to the end of the file and from that end it will read 6 characters. So let us see what happens here. If you run the code, nothing is being printed because from the end there are no data exist inside the file. So if you open the file cat myfile, you can see this is the end of the file, right? So this is the end of the file. From this end, if it tries to read 6 characters, nothing exists. That's why the output is empty when we run the code. So because this is all because the value 2 given in the seek. So in the seek, if we give 2, what I am now trying to do is it is not after the end, I need to read before the end. So what I'm going to do, I need to put it as -6. What does it mean? So after the end of the file, the Go compiler will not search for any data because the seek variable is a negative variable. So it will from the end, it will search and take 6 characters before. So what will happen now? See here, string. So this is from the end, it is an empty space. From there, it takes the data as string here. So this is how the second argument in seek works accordingly based on the file position, whether it should be read from the index, whether it should be read at the current file pointer position, or it should be read from the end of the file. So it is unusual we used to follow this 2 and all. We regularly follow 0, which is from the file beginning we usually read. So let us keep this for now. So whenever you want to read from the end, you need to use negative characters. Then only it will read only from before the particular index. So this needs to be remembered while reading from the file. So now I reverted everything back into the old position where it reads from the beginning as 6 characters. That means 6 bytes. So if I run the code, world is being written instead of hello. So this is how we need to use the seek statement for file related operations. Right. So this is one another way of reading the data. So we have one more way to read the data from the file. So this is how we will read the data from to a byte array. So we need to seek to a particular position. From the seeked position, we are going to read some set of data. We have one other way through which we will read the data. So what I am going to do now, I am going to already the file pointer is at the location 6 now. So I am going to reset it back to 0 0. So how to reset it back to 0 0? f.Seek 0 comma 0. Now if I try to read the data, it will read from the index. Fine. So it will read from the index and 0 is the size I have mentioned. So the file pointer will be in the 0th position, that is from the hello. Now what I am going to do is I am going to create a new byte array for me. So I am going to create a new byte array for me which contains new data colon equal to make of byte array. So what does this byte array size contains? So I'm just mentioning it as again as 5. So I have created a new byte array here. So what I'm going to do here, I'm going to use one particular method which we use to read some set of bytes predefined. So how to use this, I will just tell you. So we need to use the same way how we read it, right? So now we are having seek is at 0 0. Now I am going to read the data of 5 bytes here. So what I will do, file dot read new data. So here format dot println. So string of new data. Okay. So what I'm going to do, I'm going to run the code. Sorry, it is not f.Seek, it is file.Seek, right? The object is file. Hello world. Because the world statement is being read from the place where we seek, which was 5. The hello statement is being read from the position where it is 0, because we seeked the value to 0 now. So that's why it is being read from the 0th index. So wherever we wish, we keep on seek using the seek method to move the file pointer accordingly throughout our code. So this is the way we need to use read statement along with the seek. So the seek statement helps us to move the file pointer and read some set of defined bytes from the file wherever we need. So this is all about reading and writing from or to a file using the OS package. So please add your comments or suggestions or anything if you have in the comment section given below. Please click the subscribe button. Don't forget to click the bell button. This bell button will help you to get posted whenever a new video gets uploaded. Thank you for watching. In the next video session, we are going to see one more way of handling files, how to use the files in a new way. So within 2 or 3 next sessions, we will conclude the basics of Go programming language. So we will switch over to a fresh new topic after that. So I will meet you again in a next video.